Hey everybody, it's Miss Sullivan, and today we're going to have a chat about indices. What do we mean when we talk about indices? It's basically a shorthand way of expressing an idea where you've got a number multiplied by itself. 1, 2, 3, 4. We know that 2 times 2 times 2 times 2 equals 2 to the power of 4. That's called index notation. So just a little reminder with index notation, often we'll see, so that time 2 was my base, this time I've said x is my base. Remember when we talk about x, it's the variable or the pronumeral. It's usually the thing we're trying to find out the value of when we're doing algebra. So x is my base, 3 in this case is my coefficient. So it's the number that I'm going to multiply this part by. But my base I'm going to times by itself n times. I'm going to raise my base to the power of n. So this little thing is called the index, the order, or the exponent. Just a little way to remember that is order of operations. Some people say BOMDAS, some people say BODMAS. Doesn't really matter which order you do your multiplication and division in, moving left to right. In this instance, we know that that's brackets, and the O in this instance is for order. Brackets, order, multiply, divide, add, subtract. Some people say BIDMAS. They're saying the exact same thing. The I in this case stands for index. So brackets, index, divide, multiply, add, subtract. All right, we can do even more using index notation by applying index laws. And when I say even more, I mean do things even faster. But when we apply index laws, we have to remember we've got to be working with the same base. So if I want to apply index laws, my bases must be the same. So let's have a look at our first index law. Our first index law is multiplication. So if I'll do the example and then we'll have a look actually. Let's look at this one. 2 to the power of 2 times 2 to the power of 3. I know that that actually means 2. Just note here, I'm going to use dots instead of the multiply sign because when we're using x as a pronumeral, x and then the x for multiply gets confusing. So that little dot is taking the place of the multiplication sign. So let's go back to this. 2 times 2 times 1, 2, 3. Let's count it up. 1, 2, 3, 4, 5. It equals 2 to the power of 5. But a much faster way of doing that would just have been to have said 2 to the power of 2 plus 3. 2 to the power of 2 plus 3 equals 2 to the power of 5. When we're working with the same base, the law is, or the shortcut, is a to the power of m times a to the power of n equals a to the power of m plus n. Excellent. Working with the same base. Now, we can still use that when we've got more than one base in a sum. We've just got to be really careful with our grouping. So, let's have a look at this sum here. Let's say we've got 2x squared times 3y times 4 x to the power of 4 y to the power of 3. Okay, we've just got to be really careful with our grouping. So this is, let's do our coefficients first. 2 times 3 times 4. I just like to make sure that I've got rid of things. That's why I tend to cross them out, but you don't have to at all. Now I'm going to multiply this by x to the power of 2. Where's my other x? There it is. Plus 4. And I'm going to multiply this. Now basically when we don't have a power, that number is to the power of 1. I'm not multiplying it by itself. It's just 2 standalone. So y to the power of 1 plus 3. And I've got rid of everything. Brilliant. So let's simplify. 2 times 3 is 6 times 4 is 24. times x, 2 plus 4 to the power of 6, times y, 1 plus 3 to the power of 4. Excellent. Remember, we can even get rid of these two and express this as 24 x6 y4. Brilliant. All right, I was going to hit pause, but I'm not going to. I'm going to move straight on to dividing. So index laws involving division, where I've got the same base. So super fast, let's have a little look at what happens if I've got something like 2 to the power of 5 divided by 2 to the power of 3. I know that equals 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2, 2 to the power of 3. I can use my cancelling rules to cross that out, cross that out, cross that out. So if that's 1, that's 1. Excellent. 2 to the power of 2. 1, 2. 2 to the power of 2. It's really 2 to the power of 2 over 1, isn't it? Because that when we cancel something out, we know that that comes to 1. But this is a whole number. We know that anything over 1 is a whole number, so we just write it by itself, and it equals 4. But a faster way of getting there would have been to say 2 to the power of 5 minus 3 equals 2 to the power of 2, and we know that that equals 4. So the rule for division using index laws is where I've got the same base, a to the power of m divided by a to the power of n equals a to the power of m minus n. Excellent. Again, let's try and step it up a notch and make that a little bit more complicated, and we'll involve some coefficients. So we'll say 24 let's go 24a 8 a to the power of 8 divided by 4 a to the power of 6. So what I know I'm doing there is I'm saying 24 over divided by 4 times a to the power of 8 divided by a to the power of 6. Excellent. I can now use cancelling laws. 4 goes into itself once. 4 goes into 24 6 times. So this just becomes 6. I know that this 6 is going to be cancelled out. 8 minus 6. And we're going to get 6a squared. Excellent. Let's have a look, just like we did with multiplication, at what happens when I'm working with more than one base. Again, it's just about grouping. So we've got to be very careful. Let's try 4 x to the power of 4 times 9 y to the power of 6, and we'll divide that by 6 x to the power of 2 times 2 y to the power of 5. Okay, again I'm going to look at my coefficients first. 4 times 9, let's get rid of that first. 4 times 9, 36, divided by 6 times 2, 12. Excellent. Now I'm going to look at my x's. X to the power of 4 divided by x to the power of 2 times y to the power of 6 divided by y to the power of 5. All right, again, 12 goes into 12 once, it goes into 36 3 times. So this one becomes simplified 3 over 1 times. Well, I can get rid of that. 4 minus 2. Well, it's not really getting rid of it. Really also becomes 1. X squared goes into itself once. 4 minus 2 x squared over 1 times. And again, I can get rid of this, 6 minus 5, and I'm going to get y to the power of 1 over 1. These are all over 1. They're whole numbers. So when I write this up and I simplify it even further, remember we get rid of these. And it just becomes 3x squared y. Excellent. I hope that's helpful. Stay tuned for looking at our next law, which is rules for to the power of 0.